So in order to solve this puzzle, you need to know a few things about biogeochemical cycles in the ocean. And I already introduced you to the key concepts. So what you need to know is that bacteria remineralize detritus into dissolved compounds. Okay, so it's the dead organic matter that falls through the water column that creates dissolved nutrients at depth in the ocean. At the same time, this process uses up oxygen. Okay, it's called oxidation of organic matter. So now you just have to imagine that you are a water parcel that moves through the world ocean, and you are created through deep convection, either deep convection in the North Atlantic or slope convection on Antarctic shelves. The main driver is North Atlantic deep water, so imagine that you are starting in the North Atlantic. So what happens now as you move along, there's this rain, okay, this marine snow of dead organic matter which becomes converted into dissolved oxygen. So it's not that hard to imagine that if you move with the North Atlantic deep water, that your dissolved nutrient concentration will increase during the movement, during your passage from the North Atlantic into the North Pacific. At the same time, if you start with a relatively high oxygen concentration, and in the deep ocean there is no source of oxygen, so all that can happen is that your oxygen concentration will decrease because the bacteria use up oxygen during this process. Okay, so as you move from the North Atlantic to the North Pacific, your oxygen concentration. In addition to that, you also have a little bit of influence of what comes from the Antarctic slope. And at that time, when Broca discovered or proposed this deep circulation, it was known as Weddell Sea bottom water. At that time, people were not aware that there's also water formed in the Ross Sea. Okay, so this is how Broca discovered the deep circulation or the Great Ocean Conveyor Belt.